Hello Year 8, this is lesson 4 from the Forces, Waves and Generating Electricity booklet. I did say that we go through this homework, so here we go. Question 1. Forces can be a twist, yes, they can be a push for 1 mark and a pull for 1 mark. Can you name 2 non-contact forces other than static electricity? Gravity will be one of them, and magnetic fields are the other. Lightning is the flow of negatively charged electrons through the air. Question 4. When like poles on a 2-bar magnet are brought close together, they repel. That will be true. And the last one, name the units for measuring forces. They are newtons or capital N. Give yourself a mark out of 7. Now, this concept of resultant forces. A resultant force is a single force that has the same effect as all the other forces that surround an object. If the forces are in an opposite direction, you take them away, you subtract. If the forces are in the same direction, you add them together. Here's a couple of examples. We've got these identical twins in a tug of war. One is pulling one way, one is pulling the other. What we do there, of course, is they're in opposite directions. We take them away. So the resultant force, the single force, is 1, take away the other. So that will be 78, take away 78. And that equals 0 newtons. The forces are balanced, and the tug of war is still stationary. Now, example number 2. It's a tug of war between identical twins, but the twin on the right has been eating well and weight training down the gym. He appears to be stronger than his other twin. Now, to work out the resultant force, it's given the symbol RF. They're in opposite directions, so you're going to take them away. And what you tend to do is put in the biggest value first. So it's 97, take away 78, and that will give us a resultant force of 19 newtons. And obviously it's going to be pulling towards the stronger identical twin. So describe the motion. It moves to the right towards the stronger twin. In this example, we've got a parachutist. Their weight force is 800 newtons, and don't forget all those billions of air particles underneath the parachute creating air resistance is also 800 newtons. So our single force that replaces all the other forces but has the same effect is 800. Take away 800 gives us a force of 0 newtons. Now you've got to be careful here. This parachutist is obviously not stationary, so describe their motion. They are moving downwards at a constant speed. Remember, if forces are balanced, the object is either stationary or it's moving at a constant speed. And this individual is moving at a constant speed. The forces are equal but opposite. They are balanced. Now, I do like this example. We've got Santa on a sledge being pulled along by 4 huskies. And let's have a look at the forward forces. We've got 4 huskies. 1, 2, 3, 4. Each pulling with a different forward force. To work out the total forward force, we add up all those forces. 37 plus 19 plus 23 plus the strongest 48 gives us a total forward force of 127 newtons. But you've got to take that away from all the air resistance and friction. That will be 12 newtons. So the overall resultant force will be 127. Take away 12 gives us 115 newtons of force to the left. So the motion, the sledge and Santa and the huskies moves towards the left. Now, do objects always stay still? Do objects only move at the same speed? What can objects do instead? When the 2 forces acting on an object are not equal in size, we say that the forces are unbalanced, and that is exactly what has occurred in this example here. The forward force from the huskies was 127 newtons. The air resistance was only 12 newtons. The forces were unbalanced, and the resultant force was 115 newtons to the left. The forces were unbalanced. If the forces of an object are unbalanced, the object will speed up. It will accelerate. And that's exactly what has happened here. The forward force from the huskies is much larger than the air resistance. So of course, this sledge is going to speed up. It's going to accelerate. So we could have been much better with our description. Yes, the sledge moves towards the left, but in actual fact, the sledge accelerates towards the left-hand side. So, speeding up is accelerate or acceleration. Slowing down we call decelerate or deceleration. So, just to recap, if the forces on an object are unbalanced, that object will speed up, it will accelerate. Or other examples will show that they will slow down or decelerate. They can even change direction. Here is an example of unbalanced forces. We've got a greyhound. He's able to run at 45 miles per hour. That is quick. We've got the 2 horizontal forces. His forward force is 79 newtons. The friction between the dog's paws and the ground, and he's going to be moving through air, so there's going to be air resistance, is 42 newtons. The forces are unbalanced. Let's have a look at these questions. Question 1. Were the 2 forces acting in opposite directions? Yes, they were. Were the 2 forces equal and acting in opposite directions? No, one was much larger, so that's a no. Were the forces balanced or unbalanced? They're definitely unbalanced. This one is much larger. Was the dog speeding up or slowing down? Because the forward force is larger than all the friction forces, he's speeding up. Speeding up. What is a better word than your answer to question 4? Oh, if he's speeding up, he is accelerating. And the resultant force, remember, RF equals, now because these forces are in opposite directions, you take them away. 79 take away 42. Always use the larger one first. 79 take away 42 equals 37 newtons. And in which direction is this resultant force acting? It's acting towards the right. Let's have a go at this example. The car is braking. You can even see the dust coming off the tyres there near the front wheel. But it's still moving forward. It is not reversing. This car is braking. It is moving to the right. It is moving forward. Now, the forward force is 85 newtons. But friction between the tyres and the ground and the brake pads as well, and the brake discs, and air resistance is much, 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 much larger. This car is still going forward, but the braking force is much bigger than any forward forces. Now, question 1. Were the two forces acting in opposite directions? Yes, of course they were. Were the two forces equal? No. Were the forces balanced or unbalanced? They were unbalanced once again. Was the car speeding up or slowing down? It was certainly slowing down. What's a better word for your answer to question 4? Slowing down is decelerating. There's only one C here for decelerating. Now, calculate the resultant force. The RF, the resultant force. Do the bigger one first, 147. Take away the smaller one, which is 85. And that equals, using my calculator, 147, take away 85, gives us 62 newtons. The resultant force is a single force that has the same effect as all the other forces. But what's the direction? It's in this direction. It's in this direction. It's to the left. It is slowing down. Final section is homework number 2. It's out of 8. So you've got to label up A, F, B and C and put it into the correct box. That's worth 4 marks. And then question 2, which two forces will be balanced even if the snail accelerates? And then question, naughty, that should be question 3. Question 3, which two forces will be unbalanced if the snail accelerates? We will look at this next time. See you next time.